Welcome back to the second post in what may become a series about me learning enough to build and maintain a web application that accomplishes something practical to help my team at work. As I mentioned before in my previous video, I need to learn a lot of different technologies, but first I'm going to start with a Python project. Now at this point, I assume that you have browsed through a Python book or worked through a series of Python training videos. Haven't spent too much time on it, but you've learned the basic syntax and you're ready to get started. In our training labs, we use the Guacamole proxy server to serve user interfaces to students. Each lab is completely isolated from our corporate network and has its own Guacamole server, so we don't need a database or LDAP authentication, which simplifies the Guacamole installation. I configure users and devices in an XML file named usermapping.xml. Every student has access to the same devices, so I have to repeat the same information in the file for each student. Many devices are similar, except for their names and management IP addresses. Building and updating this file is a tedious and error-prone copy, paste, and edit process. I will write a Python script that will build the user mapping XML file for me. First, I'm going to create a simple script that works for my specific situation. Then I'll try to generalize it so others can use it. As I do this, I expect to learn more about the modules and packages available in Python's standard library. First, let's look at the problem. Here's an example of a user mapping file. This is the Guacamole default authentication file format. It is a shortened version of the usermapping.xml file that I use in my labs. This file authenticates two students, each of which accesses 4 devices. So here's the student number 1, there's student number 2, and each student accesses devices named router 1, router 2, server 1, and server 2, and each device has some parameters that tell Guacamole how to access it. This is the file that I need my program to create. The first thing we need to do is make sure that Python is installed. So I'm going to open up a terminal with the Control-Alt-T key combination, and I'll just snap it to one side of the screen, and I'll check what version of Python is installed on my system. Okay, we see Python 3.8.2 is installed. We'll use the system version of Python for now. Later, as you get more advanced, you will want to work in a specific version of Python, and you may want to install additional packages. For example, if you're developing a web app that will run on a public cloud provider's Python service, you may need to use a specific version of Python that they support, and you may need to install packages provided by the public cloud vendor. When we get to that point, we'll learn about managing different Python versions on the same system and using virtual environments. But we're just starting with the basics. At so many points, we will find ourselves tempted to dig into some peripheral topic, such as text editors, frameworks, or plugins. But let's resist that for now. We want to get started fast, and we'll learn those topics when we need to. I want to see how I can run Python on my system, so I'm going to create a classic Hello World application like this. First, I'm going to create a directory for my project. And since eventually this project is going to be used for my user mapping file, I'm going to call the directory usermapper. And I'm going to switch to that directory. Now I'll edit a simple test program called helloworld.py. And you should name all files containing Python code with the .py file name extension. I'll just create this using the standard text editor that came with my system. Search for text editor, there it is, and open it up. Every operating system has some standard text editor. The first line in a Python application is usually going to be what's called the shebang, which is just a line of text that tells the system which interpreter or which shell to run this script with. In Ubuntu, you have to call Python 3 because that's just the way it's set up in Ubuntu. Other systems may just call it Python. Then we'll just type in some text that just prints out the string hello world. Again and again. I'm not explaining how the syntax works here because I assume you've been reading a book or looking at videos and you've already learned the basic Python syntax. Now we'll save it to the directory that we created. And we'll give it the name hw.py. Oops, I meant up here. hw.py. There, now it's saved. Now I should be able to run it here. And the easiest way to run it is just to type Python 3, which runs the Python 3 interpreter, and then point it to the file. I've got a syntax name error here. The nice thing about Python is it gives you these nice error messages, and I think that I need to have the capital T in true because that's what the Boolean should look like. Save it and then just run it again. There it goes. Now I'll quit with the Control-C. You can see that it opens up another error message, and this time around it stopped because it received a keyboard interrupt. We'll probably see these messages lots as we work through Python. Another way to run Python in operating systems like Linux and Mac OS is to change the permissions so that it becomes an executable file and then just call the script directly. So for example, I can make this script executable with chmod +x hw.py, and now I should just be able to run that directly. There it is. Another thing I can do is copy this file to my bin directory, and then it's in my path, and I can run it from anywhere. But we'll get into things like that later. I'm going to close my editor and delete this file. Okay, so let's start up another editor. I need to create a data structure to store my data in memory so I can manipulate and organize it. Since the XML file I'm trying to create will contain data in key value pairs, a Python dictionary is probably the best way to structure the data. I'm going to build my data structure as nested dictionaries because, as you saw in that XML file, I have 3 levels of hierarchy. I have students and then devices, and every device has a set of parameters. The parameter structure needs to be nested at the deepest layer, so let's start with it. I'm going to name it SSH params. So the protocol will be SSH. The host name will not be defined right now. Oh, and those passwords should be in quotes because they're strings. And we end with the bracket. I'm hard coding values, and that's not the best way to develop reusable code, but I'll fix that later. We're just trying to get started and see how this works. Now, the devices dictionary consists of 4 devices, so we should create 4 new parameters dictionaries by assignment, 1 for each device, like that. I'll put some spaces in here so things are easier to read. I basically assign SSH parameters directory to router 1 parameters. I do it again for router 2 parameters, 3, and 4. So I've got 4 sets of parameters. Then I create a dictionary called devices. And as you'll recall from reading about Python, just defining a dictionary creates the dictionary. We don't have to do anything special. Just this text here where I just use the squiggly brackets, it tells Python that this is a dictionary. Now there are 2 students we need to create. So we'll create a devices dictionary for each student. So I'll assign the devices dictionary to a unique dictionary called S1 device, and I'll do the same thing for another dictionary called S2 device. Now these dictionaries are actually nested dictionaries. We have a parameters dictionary instance nested under an instance of a devices dictionary. And then this nested directory and this nested dictionary is going to get nested under a students dictionary. So I'm going to create a students dictionary, give the students names. So student 01 is going to that's going to be that student's name, and their dictionary is S1 device. And you can see in this dictionary structure that the student's 01 key points to a nested dictionary. And there's student 02. Okay, so then we'll save this file. And we need to call it something. I'm going to put it into the user mapper directory, and I'm going to call it usermapper.py. All right, great. Now if I come over to here and I run that file, there, it ran without errors, but there's no output because it's just creating variables in memory. It's not doing anything with them and not outputting them. So one way that I can play with this is to start the Python interactive prompt. If you just start Python with the Python command, or in this case Python 3, you're running Python. Every command I type here, every statement or expression is really a Python expression, and it's going to change things in memory as I go along. Now, as you've probably read in whichever book or videos you've been looking at, you can import code into Python using the import command. So that's what we're going to do here. We're going to import the usermapper.py program. We're already in the directory where it exists, so we just call it directly, and we don't use the .py extension that's assumed to be there. Now that I've imported it, that actually ran that code. And now this data should be in memory. So if I just type students, that should, oh, what's that now? Oh, I know what I'm doing wrong here. I've imported usermapper.py, but that's the module name. Now it has to be referenced. All the variables in that module have to be referenced by the module name. So what I need to do is I need to start everything with the module name, usermapper.students. There is the entire students dictionary. And I can also go usermapper.r1params. And there's the specific parameters for router 1. You can see how each dictionary is nested inside the other. And now let's test that we can access items using dictionary keys. So for example, if I go usermapper.students and I key in on student 01, what do I get? There is the dictionary structure just for student 01, and you can see it's got the router, the different routers, servers, and the parameters for each one. And I can have like double keys. I can then reference, say, server 1. So what's that doing is looking for server 1 under student 1 in the dictionary students, and there is the parameters for server 1. To quit the interactive prompt, use the quit function, and you have to put those brackets after it because it is a function. It's a Python function that quits the interactive prompt. There, now we're back to the shell prompt. As a final step for today, I'm going to create some logic that's going to update empty fields in this data structure that I've created. In this nested dictionary, you can see that the only blank field right now is the host name field in each device's parameters. I expect that that's something that will change depending on what lab I'm setting up. When this program is done, I'll have a skeleton data structure like this, and then I'll have to have some sort of list of parameters that need to change. For now, I'm just going to make that another dictionary in the same file. So I'm going to create an IP addresses dictionary. I'm going to call it IP. And I'm going to put in the IP addresses for the devices that I want in this particular version of the file. I'm just going to paste that in for speed. Router 01 has IP address 10.0.10.1 and so on. Now I need to create some logic that is going to read through the IP dictionary, pick out the correct IP address for each device, and insert it into the parameters for each device in the larger nested dictionary. I need to think about the logic that I'll use to iterate through the nested students dictionary to get to the point in the lowest level dictionary, which is the parameters dictionary, where I can insert these IP addresses into the host name value. A nested loop is probably the best way to go, where each loop iterates through a different level in the nested dictionary. I'm going to use a for loop because that's the classic iteration loop in Python. For S in students, we'll go through each key in the dictionary students, and that's at the top level, so that'll give me student 01 and student 02. For D in devices, we'll go through the keys in the devices dictionary, which will give me router 1, router 2, server 1, and server 2. And then at this point, I'm going to reference the host name key in the devices dictionary in the students dictionary. So I'm going to go students with the S key, the D key, and that S or D will be will point to a string, which is like students 01 or students 02, for example. And then the key value in the parameters field that I want to change in this case, I'm just hard coding this in, is host name. The value that I'm going to assign to that is coming from the IP dictionary. And since the IP dictionary is also using the same device names that I have in the devices dictionary, I'll just reference the names coming from the devices dictionary. So that's D. This is kind of a hack. It doesn't really look great, but I think this will work. Okay, so I'm saving this now, and let's see what happens. Well, it ran. That's good. Rather than go back to the interactive prompt, I'm going to just put a print statement at the bottom of this file that's going to print the whole student's dictionary. And then we'll run this again. There we go. That does not look right. I see that the IP address for every device is 10.0.10.102. And that's not right. There should be two nested dictionaries that have the same values because we always have the same values under each student, but they should be 4 different IP addresses. There's probably a simple explanation for this problem. One way to find out more about what's going on is just to throw in some extra print statements inside the loop and see what's going on at each step. So here in the inside of the loop, I'm going to see what value is IP reference D in the IP dictionary. So I'm going to print IP and then just IP bracket D bracket. And that should give me the IP value it's reading. What's actually getting assigned to the dictionary, I'll make sure I know that's in the dictionary. So I'll go, that's the host name. And then I'll just copy that whole thing. And then I'll print the whole student's dictionary as it should exist at that point in time. There, and since I've done all that, I don't need this last print. Okay, let's see what happens. I'm going to run this program, run Python 3 usermapper.py, and there's a whole lot of text there, so I need to scroll up to the top and see how things get started. Okay, so here it is getting started, right here. The first IP it's reading is 10.0.10.1. That's right. It's correctly being assigned into the dictionary. But then when I look down here in the students dictionary, I see it's 10.0.1 everywhere. Same thing's happening down here, 10.0.2 everywhere. Now I know at this point, it's only assigning it in one place. It's assigning it in one of the parameters dictionaries under one of the devices under one of the students. And yet, boom, it's suddenly everywhere. And now I realize the problem. The problem is the way I'm assigning dictionaries. In my last video, I kind of said that that Learning Python book was maybe a little bit too much, that he went into too much detail in some areas, but maybe not. Maybe he was right. I recall that he spent quite a lot of time talking about the way objects work in Python, the way that basically objects and variables work together, that a variable is just a pointer to an object. You can have multiple variables pointing to the same object. And then you have this issue with mutable and immutable objects. And you have to be careful with mutable objects in memory, because if you have two names pointing to the same object, somebody changing it through one name could change it, but you might then come in from another name and expect that it's not changed, but it is. I'll have some links to a few resources from the internet that help explain this better below in the notes. But basically what's happening here is I've got the exact same object being referenced multiple times. For example, if I go up here, I assigned the SSH params dictionary to the R1 params variable. Then I did the same thing here. I assigned the exact same dictionary, that's the exact same object, to another variable. So what's happening is I have four variables all pointing to the exact same object. And when someone comes along, when a script comes along and places the host name value in here, it's placing it, it's changing it in the SSH params object, which is pointed to by four different objects, which is why it shows up in four different places here. And then the same thing happens down here with the devices. I'm S1 device, I'm assigning the devices dictionary, which contains four pointers to the same SSH params dictionary. I'm assigning it to S1 device, and the exact same thing. I'm assigning the exact same object to S2 device. So I've got two names pointing to the same devices dictionary, and that's why, and the devices dictionary points to the exact same SSH params object as you go further down. So that's why everything's instantly getting populated when I do this once. So I need to make copies of the dictionaries and then point the new names to the copies. I hope that's clear. So one way to do to copy a dictionary is just to use the dictionary function. The dictionary function creates a new dictionary from a set of key value pairs that you pass to it. So I just type dict and put that in brackets and do the same thing for each one of these SSH params dictionaries. And they all need to be terminated by brackets. So this command is going to make a copy of the SSH params dictionary, and the R1 params variable will point to the new copy. So I'm creating a totally new object, and I'm pointing R1 params to it. And down here, same thing. I'm creating a totally new object, and I'm pointing R2 params to it. That solves the problem there. Then when I go down here, I can do the same thing. I can make a copy of the devices dictionary. And again, I'm creating a totally new dictionary object and assigning a variable to it, a new name to it. And this new object is going to contain the devices dictionary, which has these keys, router 01, router 2, etc., all pointing to these unique copies of the SSH params dictionary. So I think this should solve the problem. So let's just run this script again. And let's go up to the top. Okay, so here, IP 10.0.1, hostname 10.0.1, I should see the IP address entered in here. There it is. And I see that the next hostname is blank because it hasn't iterated through. But I see down here under the next student, under student 02, the hostname has also been filled in. And that should not be filled in yet. It shouldn't fill that in until it gets to the student 2 loop. And it's still on the student 1 loop. So I'm still pointing to the same object somehow. And again, from that Learning Python book, the author spent a couple of pages talking about copying nested objects. And one of the main points he made was that when you use dict, or for example copy, there's a copy function as well, to copy an object, you only copy it at the top level. So you copy its keys and then you copy its values. And if its value is just a reference to another object, then you're just copying that reference. You're not really making a new copy of the object. The object stays there and is still the same object. What's happening is I have a devices dictionary here, and it's unique, and I'm making a copy of the devices dictionary, but when I copy the devices dictionary, it's only copying this reference to R1 params. So I get basically the same reference in two places, pointing to the copy of SSH params that is referenced by R1 params, or basically that new object. But that new object is now referenced from two different places in this nested dictionary structure. So I need to do something called a deep copy. I know from browsing through the Python standard library that there is a Python copy module, and that copy module has a couple of functions built into it. One of the functions is called deep copy, and the deep copy is going to copy every object in the nested dictionary structure, and it's not just going to copy references. And it also has a copy function. And I suppose if I'm using deep copy, I should also use copy, just to be clear what's going on in the program. So I'm going to import that module into this program. It's just in the standard library, so I don't have to do anything more than just import it. Import copy. Now at this point, as we've seen before, I'm going to have to reference every function by first referencing the module name. So I'm going to have to say copy.deepcopy and then the dictionary that I want to do a deep copy of. But I want my code to look a little bit cleaner. I'm going to use a different command to import just the functions that I want to use from the copy module. So I'm going to say from the copy module, import copy and deep copy. Now those function names copy and deep copy are available directly to my program. I'm going to change the dict function to the copy function. And here for the S1 device, because this is now a nested dictionary, I'm going to use the deep copy function. If I save that, now this should produce some different results. I'm kind of tired at looking at this output. It looks a little bit hard to read, so I'm just going to add an extra line between each of these stanzas. So if we start working our way up to the top here, I can see that my first iteration, I should see that the host name for router number 1 gets filled in for student number 1, but not for router number 1 for student number 2. And if I look down here, I can see that router number 1 for student number 2 still has a blank host name. So excellent, I've solved the problem. I can verify that by just scrolling down further. I can see, for example, at this iteration here for router 2, it fills it in here, but not under student 2. Server 1 gets filled in, and then I have to go all the way down here until it starts filling in student 2 to see where it starts filling in host name for router 1, then host name for router 2. So it's going through the nested loop the way I expect it to, and things seem to be working. So the copy and the deep copy functions solve my problem. So at this point, I have a data structure created, and I have some logic that will insert values into that data structure based on a set of keys that I have in another file, or in this case, just in another dictionary in the same file. There's more work required here. I need to create the actual output file, and I'll do that on another day. I have to create an output file for the XML code that I'm going to create, and that means I have to use Python to work with my operating system's file system. And I also need to figure out how to traverse this nested dictionary structure and take each of the values out of it and put it in the appropriate place in that XML file. Well, this has been interesting. I didn't realize I'd get into all of this fairly advanced object stuff right away. And I guess that's what happens when you don't go through all the exercises in the books and every little exercise build up your skills. I just browsed through the books and then started trying to do something practical and immediately ran into one of the problems that was well covered in one of the books. But I learned a lot. That's great. And I'm making some progress towards getting my project done. And I don't think it slowed me down very much. So this approach is working for me so far. Thanks for listening.